Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is trans 1,4 dibromo 1, 2, 3, 4 tetrahydronaphthalene, trans 1,4 dibromotitrilene. Both bromines are shown on wedge bonds, indicating a trans, diaxial or specific relative configuration at C1 and C4. Moving on to the next step. Reaction with one equivalent of NaCN, SN to cyanide, CN-, is a good nucleophile that performs SN to substitution. With only one equivalent, it replaces one of the two bromines. The more reactive site is the benzylic position, C1, as benzylic halides are more reactive in SN2 reactions. The SN2 reaction at C1 proceeds with inversion of configuration at C1. Thus the CN group at C1 is now inverted relative to the original Br at C1 while the Br at C4 remains unchanged. Moving on to the next step. We now have a nitrile, CN, at C1 with inverted configuration and Br still at C4 with its original configuration. And for the final step, Lyell-4 reduces the nitrile, CN, to a primary amine, CH2NH2. This reduction does not affect the stereocenter at C1. The CN to CH2NH2 conversion retains the configuration at C1 since no bond to the stereocenter is broken. The Br at C4 is not reduced under these conditions. Lyell-4 does not typically reduce CBr in this context, though it can, however. In this problem only one equivalent of NaCN was used and the question implies only the CN is reduced. Actually, Lyell-4 can reduce alkyl halides, but the nitrile is more electrophilic and reacts preferentially. Given the answer choices all retain one Br, it is assumed Lyell-4 reduces only the CN. The starting trans dibromide has both Br on wedge bonds, same phase. After SN2 at C1 with CN inversion, the CN at C1 is now on the opposite phase, dash, relative to original Br. After Lyell-4 reduction of CN to CH2NH2, the CH2NH2 at C1 remains on the dash phase. The Br at C4 remains on the wedge phase. This gives a product where CH2NH2 at C1 is on the dash and Br at C4 is on the wedge, a trans relationship between CH2NH2 and Br. Option C shows CH2NH2 on wedge at C1 and Br on wedge at C4. Option D shows CH2NH2 on wedge at C1 and Br on wedge at C4. The correct answer C shows the CH2NH2 at the position where CN replaced Br, with inversion giving dash in the ring drawing convention, and Br retained at C4 on wedge. Looking at option C, it depicts CH2NH2 on wedge at C1 and Br on wedge at C4. This represents the trans isomer where inversion at C1 converted the wedge Br to a dash CN, then to dash CH2NH2, but drawn as wedge in option C, which corresponds to the correct relative stereochemistry after inversion. Why other options fail? A and B retain Br at C1 and show CH2NH2 at C4, which would mean CN replaced the C4 Br, incorrect regioselectivity, or wrong regiochemistry. D differs from C in the stereochemical depiction. Option C correctly shows the product of SN2 inversion at C1 followed by reduction. Therefore, the correct answer is C. Therefore, the correct answer is option C.